Hello, in this section I will go over deriving of natural exponential function. So derivative of natural exponential function is when the base is e. For example, y equals raised to the negative 3 over x, or y equals e raised to the square root of x. As long as the base is e, then you can apply derivative of a natural exponential function. If the base is not a natural exponential function, then you cannot apply the derivative of natural exponential function. For example, y equals 2 raised to the x. The base is 2, not e. And we will go over that. We will go over deriving when the base is not e on another section. But right now, this is when the base is e. Okay. So let's go over the rules for natural exponential functions. So rule 1, the derivative of e raised to the x is e to the x. It's actually e to the x. It's e to the x times the power. So the derivative of x is 1. So really that's why if it's e to the x, it's just e to the x. And then this is when the second rule is when the power is like other than x. So it's e to the u times du dx. So for example, what if it was like e raised to 3x? So it's just e to the u, which in our case, our u is 3x, times it by du dx. What is du dx? It's just pretty much the derivative of u, which is 3. So that's what it really means. It's just e to the u, whatever your u is, times it by the derivative of u prime. Okay, that's all. Okay, so now that we know the two rules, let's find the derivative of, let's do some examples. So let's do example 1. We have y, find, the direction says find y prime. So we have y equals 2 e raised to the 2x minus y. So our u is the power 2x minus 1, and then we just got to find du dx. So the derivative of 2x minus 1 is just, the derivative of 2x is 2. The derivative of negative 1 is 0. So you can say y prime is e to the u, which is the u is 2x minus 1. So it's just the power times the derivative of the power, which is 2. And then 2 is a constant, so you could put 2 in front of e, so it'd be y prime equals to 2e to the 2x minus 1. And that's your final answer. Oops. Yeah, go ahead and pause to write down your answer, and we're going to move on to an example. Okay, let's do example 2. So we have y equals rate e to the negative 3x. So it's going to be, what's our u? Our u is negative 3x. And then du is, the derivative of negative 3x is negative 3. So y prime is e to the negative 3x times du, which is negative 3. So your final answer can be expressed as negative 3 e to the negative 3x. Okay. Yeah, go ahead and copy that down, and then we'll move on to example 3. Okay, let's move on to example 3. So we have y. Now we have something slightly different. It is in a fraction. So we have y equals e raised to the x squared all over x. Um, we're going to use two things. We're going to use the quotient rule and the exponential rule, right? Okay, so if you recall, uh let's review the quotient rule. So quotient rule is this. If you forget, it's f prime of g minus g prime of f all over g squared. Okay, so let's first figure out our f and our g. So our f is the numerator, and then the g is our bottom, right? So f is e to the x squared, and then f prime, if you use the natural exponential, it's going to be e to the x squared times the derivative of the power. So the derivative of x squared is 2x. So really that is like 2x e to the x squared. And g is x, and g prime is the derivative of x is 1, right? So now let's just find y prime using quotient rule. So it says f prime, which is 2x e to the x squared times it by regular g, which is x, minus, and I'm always going to put a bracket, g prime, which is 1, times it by regular f, which is e to the x squared, all over g squared, so that is x squared. Okay, so I guess we can try cleaning this up. So this would be, let's see, on the top, it's 2x e x squared times it by x, so that can be expressed as 2x squared e to the x squared minus e to the x squared all over x squared is x squared, right? And yeah, you can leave it like this, or you on the numerator, what can you do? You can take out an e to the x squared. So you can write that as your final answer, or you could take out an e to the x squared, but nothing really cancels. So it's really up to you. Okay, so this is your final answer. Either you can use this or this. Okay, I'm gonna end it here. Go ahead and press pause to copy the work, and then we'll do this is example 3, so we'll do 2 more after this. Okay, okay, thank you. Bye-bye.